Hey, hi everyone. In the last video, we built a RAG agent using LangGraph, and this was the architecture of the agent. We started with the collab notebook, and eventually we had this agent which can use the RAG, which can do the web search and eventually answer the question. If you want to find the code for this, the last tutorial, you can go to the Future Smart AI blog, and you will find all the code and explanation here. You can also find the link for the collab notebook that you can directly go and use. So what we're going to do in this particular video, so we're going to build the fast API. Basically we're going to integrate the agent that we build in this collab notebook with this particular fast API. If you want to try yourself the agent, you can go to the agent.futuresmartai and you can try this agent here. So let me show you what we got here in this particular video. So we will be creating this API which will have, let's say, these 4 endpoints. So one of them is the chat endpoint. Basically you can talk to your agent which has access to your documents, and there are a couple of endpoints which you could use to manage your vector database, which we didn't cover in the earlier tutorial. So this will be the new section that we are able to add the document, list those documents, delete those documents, right? Basically able to update, because if you build any production ready system, you're going to require this endpoints, because you are not going to do this one time. Okay, so let's try this endpoint. First of all, let's see what documents we got in the system. So we don't have any documents here, so we can try and upload some documents. Let's go to the upload document endpoint. I'm going to use the same documents what we got. So we had this hypothetical document called Green Grow company. Let me execute this thing. Okay, so it is saying the document has been indexed, and it has given me the file ID that I could use for the further purpose. You can verify whether the file got indexed or not. Yes, this is the list of files that is got indexed, and I got the ID of the file. If I want to delete, I could use this delete endpoint to delete this particular thing. Now let's see whether we are able to so this is the document which has something information about some eco harvest system. So I'm going to ask some question. I just kept one notion handy here so that I can simply copy paste. So let's go here and let's try to chat with those endpoint. Maybe I don't have any existing session, so this is the first message in the session. We could use 4.1 menu, 4.1, whatever So let me ask this question, and we will see in the langsmith what is happening. So if I go to the langsmith, this is the langsmith traces, so that I could see what is happening inside the LangGraph. And you should be seeing that we got some content from the RAG which is related to, though it is not parsed well, but it is coming from the RAG agent, and we should be having the final answer from the answer node, which seems to be from 2018. Do I need to zoom it? Yes. So we got answer related to, let's say, 2018, which is something coming from this document. And if you look at again the chain, sorry, not here, so basically we had a router node which decided that we should first check in the RAG, and from the RAG lookup we got these documents. Basically if you look at the vector store, we got this couple of documents, and using those document, basically we got the answer. So you can see we got some context from our knowledge base. Now what we will do, let's see, we will delete this thing, and we will see what happens. So let me go back to here. Let's go and let's delete this document, and we're going to ask the same question again. Maybe I go there, we can list the documents. We know the ID is 4. Let's go and delete this document. Say ID is 4. It is saying the document has been deleted. Let's confirm from the we can again list documents. It is saying empty, there is no documents. Now let's ask the same question. Let me go back here and let's run the chat endpoint. Let's ask the same question. It is taking more time, but we got some random answer that it was introduced in the May 2022, which is definitely not coming from our documents. We also got this session ID that we will see how we maintain the session and what is its importance. It is very important when you have the RAG to maintain the session. Okay, so let's see what's happened inside the langsmith. If I go to the, we got something called contextualized chain, and I will be explaining why it is important. Without this contextualizing your query, your RAG is not going to work when someone asks the follow-up question. So it is very much important. that you should stick around to see why it is important. If I go to the line graph here, and let's see what has happened. So router decided to use the RAG. Here you could do one thing. If there is nothing in the knowledge base, you can even handle this case. But here, based on the question, it decided to first check in the RAG. And from the vector database, it got, let's say, nothing. There are no documents in the vector database. So if you go to, since there were no documents in the vector database, it decided to call the web search. And it did some web search, and somewhere on the internet it got some information which is not related to what we got there, and eventually the answer node has answered this thing. So we got the answer, but it didn't come from our knowledge base because we didn't have any data, and that's why we could see what was happening here. Now let me show you what is the importance of this contextualized chain, that what we're gonna see. So let me show you one thing. Maybe I will show you once we start the explaining the code. And let's start with the chat endpoint, that what we have in the chat endpoint. So let me go to my VS code. Here we got our code. So I have this API folder where I got all the fast API code, and the docs folder has some sample documents that we can upload. Then we got the virtual environment. This is where I'm running the code. So let's start with our API folder. So before we jump, we can just look at what is the requirement file we got, and basically what is the requirement file we got, and what I would say, the what is the database structure we have. So first let's look at the database structure, how we are able to handle the chat endpoints and the this document listing and all those things. I kept this Notion page handy so that we can look at. So I got basically two table. One is to maintain the chat history. So this time, earlier I guess chat history from the agent, the LangGraph agent. But here I'm putting chat history outside of the agent so that I can manipulate it, and I can store or persist in a DB. So that is where I'm creating one table called chat history. There I'm maintaining the session ID because this is the chat model. We're going to have a multiple messages inside the same chat session. As I going to show you how we are generating the session, how the session is impacting, and again that contextualizing thing. Then we're going to store what was the user query, what GPT has response, which model did we use, and the timestamp of that particular conversation. Very basic information that we maintain to retrieve the all the messages for a particular session. And then we got one more table for the document purpose. So we are just storing which file did we index and when did we upload it, and we will be deleting from it. Again, the content of the file is going into the vector database, which is the same vector DB, chroma DB, what we are using in this particular video. Okay, let's start with the okay, let's have a look at even the requirement file. We got couple of things from the LangChain. All of these are coming from, let's say, the LangChain. Most of them are LangChain core. This is for specific to OpenAI. This is for specific to, let's say, Chroma. And this is the web search we are using, the Taveli web search. The docx, PyPDF, and all these things to parse our document. So this is helping us to parse our docx file. This is helping us to parse our PDF file, and this is so that we can upload the file using FastAPI. We got FastAPI. There's the UBCon. We got the Pydantic model so that we can define the structure, and this dot environment so that we can read the environment file. Very typical Python files that we might expect, and we will see how we're gonna use them. So we start with the main file and the chat endpoint. This is where our chat endpoint that we just explored. Let's look at once again. Let me reset. What you see for the chat endpoint. So chat endpoint has this schema, input schema. So it is expecting a question that user wants to ask. It is expecting the session ID. Why it is important? Because if you want to ask a follow-up question in the same conversation, you better pass the session ID. And this session ID is generated at the backend. So I will show you how it is generated. And you could pass the models. It's better to have the choice so that UI can decide which model they want to call. And let's look at, so this is where the we got our query input that we just saw. So let's look at the query input. Those all request and response models, which is the Pydantic models, are defined in this file called the Pydantic model. And we could see that we got the query input, which just has a question, session, and model we just saw. And there is also structure to our response. So that is also defined by the schema. In the response, we get the answer, session ID, and the model that was used. So that query response is also structured is we put here, and we did similar for the document, and we also have the list of models that is allowed. If I tried something else, it will give me the error. Let's go back to again the main endpoint. So we got the query input. We just saw what is its structure, and then we call this is the response structure that we are passing. So at the end when we reply, this is the query response we are giving. Now let's say what happens when you get the request until you get the answer. The first thing we check, do we need to create the new session ID? Because the session ID generation task is at the backend. So let's see what is happening here. So we are in the utils folder. We just check, do we have the session ID provided from the UI? If not, generate the unique session ID. That's it. That's what it does. So we're gonna get the session ID either from the user or we're gonna generate it. Next thing we want to do is to see whether we have any chat history associated with that particular session ID. So we already know that there is a chat history table. So if I click on this one, we go to the database utils file, and there is a simple SQL query that goes into our chat history table and see and retrieve all the messages for that session ID. That's what we're gonna do. And then we're gonna format these messages, because we know that if you look at our schema once again, our schema has user query and the GPT response. So this is a human message, this is the AI message. So we're gonna simply restructure them. So we create our messages array such that we got the human role and we got the let's say the AI message from this. This is how we typically structure those messages. Once again, let's go back to the the chatting. So we got the session, we got its previous messages, but to pass this messages to the LangChain chain, we need to convert those messages into the LangChain format. So LangChain has basically human message format or the AI message, right? These are the typical messages supported by so we simply converting in this format. There is no logic change, nothing is happening, so that we can pass to this the prompt chain. Once again, now we got the history in the format that is expected by, let's say, both the LangChain and the LangGraph. But I told you, right, we require something to in the middle. So basically we need to something called contextualized chain. Now let me give you what I mean by that. So let's go back to this page where I put some example. Imagine we pass this thing. First query in the session, we ask, what is the green grow harvest system? So we are asking about something. Now it can go, this query is independent query. We can pass that query to, let's say the vector database, and we can get the relevant document. But imagine user asks this follow-up question, when was it introduced? And if I only take this part, when was it is introduced, which is the user's latest message, basically this thing, what we got from the user's question, if I only take this message, I will not find the relevant document, because when you try to match this query, when was it introduced, with this thing, it's gonna not, it's ambiguous query, it's not gonna match with anything. That's why whenever you have the RAG or the knowledge base, you need to convert this incomplete query into the something which is standalone question that can be matched. Again, this has nothing to do with the LLM. If you pass LLM already has a history, so you don't require this for LLM, but you require it for the retriever part, because retriever don't have the history, and you need to pass the complete, else it will give you any random thing. And that is very much important thing. I see many times, when people follow the tutorial, or the newcomers or interns, they simply miss this point, that the to make your RAG working, you need to handle the follow-up questions properly. So this thing you need to understand. So let's say how we are handling this thing, so that we can complete this message in a complete message. So let's take an example. We can try the same question here. Let's start the fresh session. So I'm starting a fresh session, and maybe I put this, what is the green grow harvest system? I might get any answer, so answer is not something that I bother. I rather want to show you how the follow-up question work. So we have, I think I should have used the mini, so that we could have got the the quicker response. We got some answer. The harvest system is something, it's hopefully coming from the document, or it might not be coming, it is coming from the web, because if there is no document, I guess we have deleted the document. So let's confirm, so that we can add the document. Let's say we can even try here and check whether there is a document or not. Okay, there is no document, so let's add the document. Where is the upload document? Yeah, here is the upload document. Let's quickly upload the document. Now let's ask the question. Hopefully you will see the quick response, because it will not go to the web search if it is able to find it inside the RAG. We can observe in the Langsmith. I think this is where our query is getting run. So we asked this question, what is the green grow harvest? So router decided to maybe use the RAG. We could see there is a RAG, and RAG was able to retrieve the relevant document. Okay, here's the interesting. You see what query is going to the RAG. RAG is getting this query. What is the green grow harvest, this whatever the system. This is fine, because this is not the follow-up question, right? And if you go back to now, to the and ask the follow-up question, I will require the session ID so that we can get the the previous messages from it. Let's put that session ID so that we can ask the follow-up question inside the same session. And let's ask this thing, when was it introduced? And let's hit it. Meanwhile, we can also check whenever we answered RAG or the router, there is no earlier previous chat history, because this was the first message inside the session. So hopefully now we have the better now let's look at what is happening in the contextualizing chain. So this is the the contextualized chain. We are using the GPT-4o Mini. We are saying that you will get the user latest question and it's a chat history, and you want to return or reformulate the question which is standalone. So we ask, so it has history. This one, that this is the history of whatever we asked. Then we ask, when was it introduced? Now it needs to convert into the standalone question. This is how it converted. When was the green grow higher? So you imagine it is able to take the history and give me the complete query. Now this complete query can be used later in the what I say, in the LangGraph thing. I don't know why it is still did we got the answer? It is still running. Okay, we got the answer. It is so this is coming from the document, because I know that it is coming from the document. Hopefully, do I need to refresh? Let's refresh this one. Okay, we got actually the LangGraph is, sorry, LangSmith is taking a bit time to refresh the records. So here I wanted to just quickly point out to you that what has happened, that when it goes to the LangGraph, our query was rewritten. When was the green grow e-harvest system is introduced? The problem with this actually is that our chat history itself has the answer, because when I ask the first question, that first question answer itself has whatever I'm asking. That is the reason it didn't go to the RAG. But you got my point, that it has rewritten our query. So if it went to the RAG, it would have written this thing. So now, since it itself has this particular answer, it didn't require need to actually do with the RAG. So maybe we can find some question that might require to go to the RAG or something. Let me check whether does it has anything that where we got. So this 40% was also part of the 30-40%. I'm just finding whether is there anything that is not in that answer at the heart of the AI center. Or I guess you got the point. What I was trying to say, rather than wasting things, that we are able to reformulate the latest user question, so that even if you call the RAG, this question itself is a complete and not ambiguous. Okay, that's what's happening in the contextualizing thing. And then once we have this thing, we take the previous messages from the chat history, take our standalone question, append together, so we got the complete history of the messages that we are passing to the agent. And this agent is the same agent what we build in the collab notebook. So there is nothing has changed for this particular agent. It's the same agent what I have in this particular notebook, only it is refactored a bit. For example, LangGraph actual agent, you will see here. Then I got other files. So basically I separated the nodes. So all the nodes are defined in this particular file. You got the router node. So I just copy pasted those functions. So nothing big deal. Rather than going through all of this, once you look at the code, since I will be also uploading this code to the GitHub repo, you can check. So this agent has the same content what we have seen the earlier. Now let's go back to again main endpoint, that after invoking this agent, we will insert the response inside the chat history, so that next time that response is available, and basically we give the query response. So this is the typical working of the the chat endpoint. So the only interesting thing here that we need to think when you do any production or something that is going to use by other services, that handling the session ID, making sure that you are generating the session so that they are able to pass the follow-up question. Maintaining the chat history, I prefer to maintain the chat history outside of the agent, rather than passing through the or remembering through LangChain or LangGraph memory. And then contextualizing this particular thing will require if your agent has access to the RAG, and you need to reformulate it to make it a standard. So this is the most important part of the your chat endpoint. The other endpoints are more of like just database insertion, all this thing. So let's look at what happened during the upload document. When you upload the document, So when you upload the document, I'm currently supporting PDF and the docx file, so I'm just checking, whether it is a part of my allowed, extension. Yes, it says that, basically typical Python code that it is not supported. Then we basically, save that file to the, temporary location, and then we got these two functions. Let's see what is happening. Insert the document record. Here we simply inserting that document record, saying that this particular file name, as a part of the document store. Why? Because we will be deleting from it, so we are just maintaining what are the files that we have, inserted. And then we will go to the actual insertion. This is where the actual insertion is happening inside the vector database. So let's look at the index document to chroma. So the first thing, we're gonna read the content and we're gonna split it into the small document. This is the same function that we had in the notebook. It simply reads. If it is PDF, it uses the PDF reader. If it is the docx, it uses the docx reader. And eventually, we use the recursive character splitter and split those into the small documents. That's what it does. Okay. So index documents. Now, once we have these documents splitted, basically here we will come, and then this is what we are doing. Since we want to make sure, we should know which chunk in the vector database belong to which file ID. And this file ID we got from the document store. So when we inserted, we got the file ID, back. So we are putting that into the metadata. So we are having each split, which is basically a document. We are adding a metadata called file ID so that we could use this file ID later for the deletion purpose. And then basically, we use this vector store, function. So what is vector store? It is just defined here. It is the chroma, vector store, where we have defined the chroma db as a directory. It is the same thing what we did in the collab. So I would highly urge you to, if you find this is very disconnected or something, go and watch this video. Without that, it will not make any sense. And so we created this vector store here, and we are just calling its add documents method, adding this document, and that's it. So what steps we did? We inserted this into our SQL database record. Then we split the documents, and eventually we index the document. Let's also look at the other functions what we got here. So this one, let's say upload document we just saw. Let's look at what happened during the list document. Is the simplest one actually we got. Basically, it just called the document store and return the file that is inserted and its ID, so that we could use during the deletion. And during the delete endpoint, this is where we need to make sure we delete from both the places. We delete from the vector database and also from the document store. So first we will delete from the vector database. So we got this function here which take the file ID we got, and then it can use, it's a metadata filtering. So basically, from the vector store, we want to get all the docs where the file ID is the matching file ID. And once we got these docs, we will use IDs, the document. Basically, these are the chunk IDs, and then we will delete using the vector store delete method. We will delete those chunks. So let's not confuse. So this file ID, first we will get the documents. These documents are nothing but the chunks from the vector database, and each chunk has the unique ID from the this chroma vector db, and the delete method requires the IDs of the chunk. That's why we are using file ID to find first chunks and then using their IDs directly here. I couldn't find a method which will directly use the metadata and delete. So basically, what if the delete takes the file ID and delete it? If you are able to find it, just comment this so that I can replace that in the next video. So this is what the deletion happens. So we just saw, where's this? Yeah. So we saw this knowledge management, endpoints, basically uploading the document listing. And this is very important if you are building solutions, in your company or for your, the client, to have this endpoint so that they can manage their knowledge base. Else they will have to send you the email, the files, and then you have to add. So basically, you give them a control. That's what we, do here. So let me see if I miss anything that I should be, telling. Else, once you got the code, you can, basically look at, everything. So let me see if I miss anything here. No, so I think main point during the integration, which I already did, the session management, the handling the follow-up question for your RAG pipeline. And yeah, so this is how we integrate the, you know, uh, LangGraph with the FastAPI. Now, let me know whether you want next part where I could, what I say, I could deploy this FastAPI. That could be the next part, or you might want to integrate the memory like a, meme0 or this, with the LangGraph. So let me know whether you are interested, so I can extend this tutorial so that we could use this memory management for our agent, which is mem0, and that's how we could extend. So either we can have the next video where I integrate the memory to the agent, or I can have a video on the deployment of this agent. I guess deploying this fast API is as similar as this particular agent. It's just same as deploying the fast API on AC2VM or something, which I already covered. If you want more complex deployment, for example, AWS ECS deployment or Fargate deployment, then we can create the video. But I guess the basic deployment I already have videos on my channel that you can try. So let me know in the comment whether you found this video useful, whether you want any other tutorial, or what changes you want me to make to this particular tutorial, so that I can at least add to the code, or maybe add it to the blog. And again, let's not forget to try the agent here. So you can go to agent.futuresmart.ai and you can try the agent here. Thank you.